Hi everyone, we are going to review a little bit of pre-cal and then go into differentiation of inverse trig functions. And I know you all had fantastic pre-cal teachers, so I'm sure you remember all this stuff, right? So just to review, and if you don't need a trig review, then you can go ahead and skip this part, but just to review, we get all of the values of the unit circle. Let me try that again. We get all the values of the unit circle from our triangles. So we have three different kinds of triangles. Okay, we have two different kinds, a 30, 60, 90. And then we have a 45, 45, 90. Right, and this is where we get all of our values from. So for a 30-degree angle, our triangle will look, remember our hypotenuse is always going to be 0 because the radius of the unit circle is 1. And so for a 30-degree angle, our x is going to be of length root 3 over 2, and our height is going to be 1/2, or our y value. And we get these because of our special right triangles. Okay, our special 30, 60, 90 triangle has these ratios between the side lengths, and it's always true. Okay, for 45, 45, 90, or for a pi over 4 radian angle, we'll have these, and then for 60 degrees, these kind of switch as opposed to 30 degrees. Right, so this is where all of our coordinates come from on the unit circle. And then also we have here our restrictions for our inverse trig functions. And you could write them with the -1 or the arc. I prefer arc because I think this is a little bit confusing. But these restrictions come from the graph of our functions, and with these restrictions, it enables the graph to actually be a function. Okay, without the restriction, then it would not be a function at all. Okay, so arc cosine, secant, and cotangent are all related in that they have the same restriction. And then arc sine, cosecant, and tangent are all related with their restrictions as well. Okay, so let's actually do a couple problems. Okay, so for number 1, we're asked to evaluate arc sine of -1/2. So if I think about this as a triangle, where this value is 1/2, then I know that this is a 30-degree angle, or pi over 6. But because this is a negative value, I know it's negative pi over 6. All right, going over here, we didn't want arc cosine of negative root 2 over 2. Now I know that arc cosine is in the first and the second quadrants, and so it's negative in the second quadrant, so my triangle will look something like this. Negative root 2 over 2. And so I know this is going to be my pi over 4 angle, but it's in the second quadrant, and so it's going to be 3 pi over 4. Okay, and this one we can't do by hand, we'll use our calculator, so if you just plug this in, so second tangent will give you arctangent, and you plug this number in, negative 0.291. All right, now we're going to do a couple of doubles here. We're asked to do sine of arc cosine of 4/5. Okay, so we got to realize that this is a triangle. So if this is my angle theta, cosine is adjacent over hypotenuse. So I know adjacent is 4 and hypotenuse is 5. Okay, so if I were to do cosine of my angle, I'll get 4/5. Okay, that's what this arc cosine of 4/5 is telling me, which means that this is a 3/4/5. Okay, now I'm asked to do sine of this angle. All of this whole thing is equivalent to an angle I'm calling theta. So I'm really asked to do sine of theta, okay, because arc cosine of 4/5 is equal to theta. And sine is opposite over hypotenuse, so sine will be 3 over 5. Okay, hopefully you're remembering some of this. All right, next I'm asked to do sine of arc cosine of x. And so same deal, I'm going to set up a triangle. Okay, here's my theta. Arc cosine, or cosine, is adjacent over hypotenuse, so adjacent over hypotenuse, meaning my side right here, using the Pythagorean theorem, will be the square root of 1 minus x squared. Okay, just use the Pythagorean theorem to get this. And so sine is again opposite over hypotenuse, so it'll be the square root of 1 minus x squared. Okay, last one, secant of arctangent of 3x. So here's my theta. Now arctangent is opposite over adjacent, so opposite over adjacent. Okay, that means that my hypotenuse using the Pythagorean theorem would be the square root of 3x squared plus 1, okay, which is the square root of 9x squared plus 1. Okay, I just used the Pythagorean theorem to get my hypotenuse. And secant is hypotenuse over adjacent. Remember, it's 1 over cosine. Okay, so hypotenuse over adjacent, so the square root of 9x squared plus 1 divided by 1. All right, let's keep going. All right, so now we're going to derive the formulas for the derivatives of our inverse trig functions. And so first I have y equals arcsine of x, and what this means is I could do sine of both sides. So that means that x is equal to sine of y. Okay, that's what this is telling me. Because remember, sine and arcsine are inverses of one another. So if I know the derivative of sine. So if I take the derivative of both sides with respect to x, I'll get 1 equals cosine of y and then dy dx. Okay, because of chain rule. Okay, now I'm solving for dy dx. Okay, I want to get dy dx by itself. And so I'm going to divide both sides by cosine. All right, so far so good, but I want this in terms of x. So again, I'm going to look at my triangle. Okay, here's what I know. I know that sine of y is equal to x. Okay, that's what I said right here. So that means I'm thinking about y as my angle. Sine is opposite over hypotenuse. Right, that means that this side right here is going to be the square root of 1 minus x squared. Okay, and so cosine of y is going to be adjacent over hypotenuse. So remember here, y is an angle in this case. Okay, the answer to an inverse trig function is always going to be an angle. And so I can substitute cosine of y as adjacent over hypotenuse, 1 minus x squared. All right, and now my derivative is in terms of x. And so this is actually true all the time. So my derivative of arcsine will be u prime over 1 minus u squared. Right, and this is just for chain rule. Right, you'll see books write it a little differently, but this is just chain rule right here. And then it's the square root of 1 minus u squared. That's where this comes from. All right, let's do another one. Let's do arctangent. So same deal, I'm going to take tangent of both sides. So I get x equals tangent of y. And if I take the derivative, that means I get 1 equals secant squared of y dy dx. And I want to get dy dx by itself. So I'm going to divide both sides by secant squared of y. And again, I'm going to look at my triangle here. And again, y is my angle. And x is equal to tangent of y. Okay, that means that x is equal to opposite over adjacent. Opposite over adjacent. Okay, we're always going back to SOHCAHTOA. That means that my hypotenuse here is x squared plus 1. Square root of x squared plus 1. All right, secant is hypotenuse over adjacent. Which is equal to just x squared plus 1. Right, so this is our formula for arctangent, the derivative of arctangent. And again, because of chain rule, I'm going to write a u prime over u squared plus 1. All right, let's derive one more, and let's do arcsecant this time. Okay, so again, x is equal to secant of y. And so if I take the derivative, I get 1 equals secant tangent, and then dy dx. So if I divide both sides again, I get 1 over secant tangent. Okay, so let's make our triangle. So my angle is again y. And I know that secant of y equals x. And remember, secant is hypotenuse over adjacent. So hypotenuse over adjacent. That means that my opposite side is going to be the square root of x squared minus 1. Okay, so let's make some substitutions. Okay, secant is hypotenuse over adjacent, so just x. Tangent is opposite over adjacent, so the square root of x squared minus 1. All right? And this is my formula. Now we're going to add one thing here. I'm going to put these absolute value bars, and it's because tangent in this case always has to be positive. And so my formula ends up being, again, u prime for chain rule divided by the absolute value of u square root u squared minus 1. All right, so long, complicated formula. All right, so I'm going to write all of my formulas out here and then do a couple examples. So arc sine, again, it's going to be u prime over square root of 1 minus u squared. Okay, for arc cosine, you could do the same thing again, just using arc cosine, and you end up getting the exact same thing but with a negative. Okay, that's the nice thing. With arctangent, it's u prime over 1 plus u squared, and arc cotangent, you get the exact same thing but with a negative. And then for arc secant, you get u prime over absolute value u square root u squared minus 1. And again, for arc cosecant, you get the exact same thing but negative. All right, so that kind of cuts down on what you need to memorize. Okay, right side is all negative. All right, so first example, we're asked to do the derivative of arc sine of 2x. So in this case, u is 2x. Okay, so I look at my arc sine formula, u prime. So that's going to be 2 divided by 1 minus u squared, 1 minus u squared. Okay, we simplify that a little bit, 1 minus 4x squared. All right, now I'm asked to do the derivative of arctangent of 3x. So u is 3x in this case. So I look at my formula for arctangent. The derivative of 3x goes on top, 1 plus, and then u squared. So 9x would go on bottom. Right, and another one here, derivative of arc secant of e to the 2x. So I look up here, arc secant. Here my u is e to the 2x. Okay, so my derivative goes on top, which is going to be 2e to the 2x. And on bottom, in absolute value bars, e to the 2x, square root e to the 4x minus 1. This is e to the 4x because I squared it. Remember, if you're squaring something with an exponent, you multiply those. All right, a couple more examples. So here, let's practice some chain rule. So my function is cosine of arc sine of 3x. So I'm going to have to do chain rule here. So I start with my outer layer. The derivative of cosine is negative sine. All right, and then I go in a layer. So now I do the derivative of arc sine of 3x, which is going to be 3 over square root 1 minus 9x squared. And I do not have to go another time because I already took care of chain rule again here. Okay, so do not do another times 3. That 3 is already right here. Okay, we already took care of chain rule. All right, last one, write in the equation of a tangent line. Okay, that keeps coming up. So first I need to figure out what my point is. Okay, I have my x value, I need my y value. So I need to find f of negative root 2 over 2. Right, so we evaluate arc cosine of negative root 2 over 2 is just 3 pi over 4. So my y value is 3 pi over 8. Okay, so now I need to find f prime of x. F prime of x is going to be 1/2 times negative 1 over square root of 1 minus x squared. All right, so I need to evaluate at negative root 2 over 2. So negative 1 over the square root of 1 minus negative root 2 over 2 squared. All right, so we do a lot of algebraic simplification here, and we'll end up getting negative root 2 over 2 is my slope. All right, so I can jump straight to writing my tangent line. Y minus 3 pi over 8 equals negative root 2 over 2 times x plus root 2 over 2. All right, that's it for these notes. See y'all later.